So this is a data set. This is the real world data set for various parameters for wastewater for an entire at least 365 values. It contains average values of all the parameters at the end of each month, which is not useful for us, but the dataset contains it. So our objective is to predict NH3 out, TSS out, and TOC out from these features. So these parameters are most tedious to measure using analytical methods by performing experiments. So we try to predict them using machine learning algorithms. So the data set contains many missing values and outliers in all the columns. So we have to pre-process the data. So the first step in pre-processing is dropping all the rows that doesn't contain any values. So for this 10th March, there are no values. So we drop the entire row. Also, we drop the values where QF uh, doesn't exist because it is the most important parameter. Since QF is the flow rate of the water, so if it is not flowing, then there is no need of measuring other features. So we also drop that column. So along with these, we also drop the date column as we don't need it for our prediction. Then we use KNN imputer to fill in the missing values in all the columns. It uses the concept of k nearest neighbor to fill missing values. So its code is available here. So we use the k value of 5 for this purpose. So after imputing missing values, we plotted box plots to check for outliers. So in this left one, you can see there are many outliers in the dataset. So we need to perform some operations. So we replace these outliers in all the columns with the mean of each column. So you can see we don't have any outliers anymore. So finally, reprocessing is completed. And now we have clean data set with 320 rows, which can be used for prediction of NH3 out, TSS out, and TOC out. So the next step is splitting of training and testing data. So we use the split of zero point 0.2 for this. So mean 20% data is used for testing purpose. Then we use feature scaling. So this class can be found in the data cleaning folder attached with the zip. So it contains all the classes, all the functions such as cleaning the data and scaling the data. So we use standard scaler which scales the data from -1 to 1. It is built in the sklearn library.
So for the prediction of the target variable TOC out, there are a lot of input features available from the dataset. So we need to find the correlation between these features so as to know which are the features which most affect the target variable. Here the target variable is TOC out. So we set a threshold of 0.4 so as to get which are the features which satisfy this criteria, and the features are COD in, COD out, TOC in, TOC out, BOD in, BOD out, TDS in, TDS out, and NH3N in for the prediction. Upon implementing various algorithms such as random forest regressor, polynomial regression of degree 2, Huber regressor, k-neighbors regressor, following results were obtained for the prediction of TOC out, and the highest accuracy for testing was found in random forest regressor, that is 0.84. These are the various scatter plots of actual versus predicted values of various algorithms. Now for the prediction of the target variable TSS out, similar correlation was being found between the input features and a threshold of zero point 0.2 was being selected, which means that at the features with the correlation value of zero point 0.2 or more and minus zero point 0.2 and less were being included for the prediction, and from the heat map the following features were being included for prediction: QF, COD in, COD out, TOC in, TOC out, BOD in, BOD out, TDS out, and NH3N in. Upon implementing the following algorithms as implemented for the TOC out results, following results were obtained for TSS out, and the highest testing accuracy was obtained for K nearest regressor of 0.7830. Here are the scatter plots for the actual versus predicted values of the various implemented algorithms for the TSS out results. Now for the prediction of the third target variable NH3 and out, similar correlation was being found between the input variables using the threshold of 0.3, and from the heat map, the input features which are used for the prediction of NH3 and out are pH in, TOC out and NH3N in. Now the results of the prediction for NH3N out are as shown using various algorithms, and the highest testing accuracy was found in random forest regressor of 0.3971. Similar scatter plots are being shown for the actual versus predicted values of various algorithms for the prediction of NH3N out. Future prospects of the domain are as follows. The dataset which we implemented had less number of samples, which led to limitations on model performance. And out of the target parameters, TOC out yields a good prediction accuracy in comparison to that of TSS out and NH3N out, unless we reduce the number of input features. And to overcome these limitations, following ways could be considered. First, the dataset could include more number of samples. Second, applying data augmentation techniques to increase the number of the sample size of the dataset. And in addition, deep learning models could be implemented to improve the prediction accuracy. And in conclusion, the implementation of the algorithms helped us to know which are the parameters which are necessary. The key role was played by the data pre-processing, which included data normalization, and the correlation plays an important role, which helps us to know which input features are most suitable to predict the following target parameters.